Alright, welcome to Solving Quadratic Equations. Learning target 4 is solve quadratic equations using all three forms, including simplifying radicals in the quadratic formula. That's really what we're going to be doing today. The three forms is the key. There's some kind of new stuff here. Not everything that's new. Like we've seen this before. It's in grade 10, but we are going to use what we learned last lesson about simplifying radicals to give exact values. We'll see what that looks like. There's quite a lot here, actually. This is a skill I want to say first and foremost. We're not always finding x-intercepts. Mostly that's why we solve quadratics, to find the zeros, find when the ball hits the ground, when the company will break even. But we're not always doing that. We solve equations a lot of the time, solve linear equations for a lot of reasons. We learned how to solve linear equations before we actually knew what a line was, or before we looked at the graph. And so we talked about quadratics, but we actually have the skill now to solve an equation that's a quadratic. That's important to understand, because when we do applications, we're not always going to get this ball being launched in the air. The picture is not always going to work nicely, and we're going to solve quadratic equations for things other than finding zeros. We can call that finding the roots. We're actually also going to solve quadratic equations just to find out an unknown value. And so the skill of solving a quadratic, it is about finding zeros, but it's not only about finding zeros. So we're going to solve the following quadratic equations. First off, we asked the question, which solution would likely be solving for zeros? And so we actually see a quadratic in standard form, in vertex form, and in standard form. So I just want you to think about that, and I want you to try to solve these. Probably best if we just walk through this, but you can try these on your own if you'd like, to see how you would do them. The first question is just saying, the ones that are most likely zeros are the ones that are equal 0. This one equals 5, so we are going to solve a quadratic, and in the process we are going to have an equal 0, but it's probably more likely that these ones are actually finding out where it is equal to 0, where the parabola equals 0. Because that is when you're finding the zeros. The point is, we're not always solving quadratics when the parabola equals 0. Sometimes we are. It all depends on the context. So likely what's the case is, it's the second and the third one are finding zeros. We're just going to go through the process of solving these. It's going to be 3 different strategies. A lot of the lesson is actually going to happen right here in these 3 examples. And then we'll do a word problem. So if you're following along in the notes, you kind of want to write a little bit smaller, or you just want to provide some extra paper. Okay, so the first thing we got to do is get rid of that 5. We got to put it in standard form. It's not there yet, so we need to get everything together. So we subtract the 5 from both sides, and we get -8 instead of -3. Now there's a couple routes here, and hopefully factoring is actually the easier route. If you're good at it, and we're also going to see that you could certainly if you're not going to factor, you probably want to use the quadratic formula. But we're actually going to see that if something's in vertex form, the middle one, we can do it that way. So this one actually can be factored 3x minus 2 and x plus 4. And just a reminder, now we're trying to find out when each of these equals 0. So if we add 2 to both sides to the first one, we get 3x equals 2. And if we divide 3 on both sides, we get x equals 2/3. The other one, if we subtract 4 on both sides, we get x equals -4. Okay, so there's your first answers for the first one. The second one, the temptation would be to expand it and then refactor it or something like that. But what I want you to challenge you to do is, if you have vertex form, you know the vertex, but you also aren't far away from the zeros. And this is actually what the quadratic formula does. So if you expand it and then use the quadratic formula, you're doing a lot of double work. And often you could make a mistake in the expanding and make it more complicated. So we're going to subtract 9 on both sides. And we're going to do something that we haven't done before solving quadratics, and it's not make everything equal to 0, but we're going to balance the equation much like a linear equation. So divide -3 on both sides, we get 3 equals x minus 4 squared. Take the plus or minus square root. This is where the quadratic formula gets the plus minus square root. It's from doing this. We did this in the first unit when we did inverses, but not specifically to solve for value of x. If we add 4 to both sides, we get something nice, but like not that nice, but it is simplified. We get 2 answers, 4 plus root 3 and 4 minus root 3. Now, if like somebody wanted the decimals, they could get them. If somebody wanted to use the number for something else, in general, we never want to round something that's not a final answer. So if they want to use these answers for something else, then they can use them. But these are roughly 4 plus root 3, which is like 5 point something, less than 6, and 4 minus root 3, which is somewhere around 1.5 or something like that. Okay. Sorry, 2 point something. The last one actually doesn't factor. And so we remember that there is a formula for it, and this is where you're going to find it. So if you want to write down that formula, a lot of us know this formula now, but I don't mind giving it to you on the test. But like you're going to use it, so you might as well know it and memorize it. The big thing is that it's all divided by 2a, not just the one part. So b, a, and c are the coefficients here. If you want to get rid of a negative sign, you can, and change this, like, because it would just divide by 0. You can change this to 2x squared minus 6x plus 3. But you don't have to. Like I did the quadratic formula with the negative. So plugging the numbers in, negative b means negative of the b value. So if the b value already is negative, you got to make it positive. It just means change the sign. So we start with -6 plus or minus. I show brackets here when I sub stuff in because like of the negative signs. It's all multiplication. But like when you're squaring b, you're always going to get a positive value. So that's helpful to remember. So do that little bit on the side, just because you don't want to keep working with the denominator. You get 36 plus 8. -4 times -2 is plus 8 times -3. You can do this in a bunch of different orders, but no matter what, you're going to get an answer of 12. 36 minus 24 is 12. This is easily the easiest, the biggest part that people make a mistake on. Just doing that arithmetic. And it's just because the negative signs, and we just got to take it slow there. We're just trying to do too much at one time. The bottom multiplies to -4. Root 12 breaks down. We can do that on the side as well. Root 12 is root 4, root 3. That's from last lesson. Becomes 4 times 3 is 12. So root 4, root 3. And so we get 2 root 3. If we plug 2 root 3 in, what the next step is a little bit confusing. It's probably the hardest thing in this lesson. But what we actually want to do is get this lower, and we actually see that there's a 2 that can come out of everything. Now, if we bring a 2 out, we don't want to leave the negative under there. And so this is why maybe it would be easier to make this a positive -6 and a positive 3 at the beginning. But what you're basically doing is just taking each of these terms, so divide the entire top, so both of these two terms, by -2, and the bottom by -2 as well. And that's what makes it look the nicest. So we get 3 plus root 3 over 2, and 3 minus root 3 over 2. And those are your answers. And then if we want to go further, we can use the decimal. Okay? So there's a lot there. I mean, if you look at that slide right now, you're like, whoa. And so it's really important just to go through it one step at a time. So go back to the golfer. He hits a golf ball from a gorge, over a gorge from a platform, and so we want to find out how long is the ball in the air. So if we want to find out how long the ball is in the air, we want to find out when it hits the ground. We know from the previous lesson when it hits maximum point, we want to find out when it hits the ground. So one of the best ways to do this is to factor it. You can take out a -5 because you don't have a complex trinomial. Things are simpler than they look. Literally, it's a simple trinomial. With simple trinomial, if you're going to use the quadratic formula, you kind of want to recognize that the -5 doesn't really matter, but this one actually factors fairly nicely. We get t equals 10 and t equals -2. So it's roughly 10 seconds. And so it kind of looks like this. And so we understand it's the -2, we call it an extraneous root. I'll put that word down in a second. But it's just the ball starts here and it hits the ground at 10 seconds. Well, now the question is, what if you already completed the square or could not factor it? So if you couldn't factor it, you could use the quadratic formula. But if you already have the square completed because you found the maximum, you don't want to go finding the factored form as well. If it's completed, and we completed it in the last lesson or 2 lessons ago, you could solve it, set h of t equals 0, bring the 180 over the other side, divide by -5, take the square root plus or minus of 36, that's just 6, add 4, and you get t equals 4 plus 6 and 4 minus 6, which gives you t equals 10 and t equals -2. So it's the exact same thing. This is better. If you've already got this form, you don't want to expand this and go find factored form. Just do this work. Okay? Just have to take it one step at a time. Again, this looks like there's a lot of work here, but we're just really balancing the equation, moving things to the other side. So t equals 10 seconds. This -2, the word we use is extraneous. It's a root that doesn't really matter. It doesn't really do anything. The only thing it really does is keep the symmetry. So it's called an extraneous root. And a lot of times with applications, you have to decide which one matters, which one doesn't. And it all depends on the context of the situation. Sometimes we think that the -1 doesn't matter, but often it does. It's not always just the -1 that doesn't matter. Now suppose there's a seagull hovering in the path of the ball, 125 meters above the ground. When will the ball hit the seagull? Assuming that he's going to hit the seagull. So we're going to sub in 125 for the height. And this is what we do. I just wanted to show this on a graph. So what's actually happening here is the height of 125, the ball is going to be launched, it's going to hit it, and it's actually the poor little guy is going to get hit again on the way back. Actually, what's going to happen is once the ball hits the seagull, oh, poor little guy, and the seagull will go one way and the ball will go another, and the ball won't continue to follow this pattern. Okay. Bring the 125 over. We're going to factor out the -5. We recognize that -5 can't equal 0, so it's t squared minus 8t plus 5 that would have to equal 0. And that actually can't So then what we're actually doing is looking at a different quadratic altogether. This quadratic has nothing to do with the golf ball except for the fact that it's going to share its zeros are going to be the same as this one's roots, which when it's at 125. So I want to show that picture because this does have a picture as well. So it is finding zeros of a quadratic, but it's not these are irrelevant. They don't mean anything. It's these points that really matter, but they're the same thing, 0.683 and 7.317. This can't factor, so we need to use the quadratic formula. We plug in negative b, so that gives you positive 8. I get 64 minus 20 all over 2. 64 minus 20 is 44. I made a mistake and I got 40. It was driving me crazy why I got them wrong. So just be careful there. Simple arithmetic that you can do in your head, just gotta be careful. Root of 44 can be broken down into 2 root 11. That's because it's the square root of 4 times the square root of 11. The 2's can come out. We end up getting everything divided by 2 on the top, and the 2 on the bottom. Gotta finish up. And the 2 on the bottom. So we divide the top by 2 and the bottom by 2, and we get 4 plus minus root 11. And so that gives you 2 zeros at exactly what we saw. And ours were potentially, Desmos was rounding a bit differently. We'll have to check on my rounding there. But I got 0.6824 and 7.317. Okay, so the seagull was hit, and then the ball likely went away from the model, or the poor bird was hit again at 7.32. Okay, and so there's your homework, and we made it for the battery.